So for this third example of graphing a polynomial, in this case, again, it's a polynomial that's not factored, but we also couldn't factor this one using our regular rules for factoring. So the first temptation, because there's 4 terms, might be to do factoring by grouping, but it won't actually get us anywhere in terms of breaking it down into factors. So this is one where we're going to need synthetic division and we're going to need the rational zeros theorem. So the first thing that we want to do is we're going to make a list of all of our possible zeros, and this is based on the rational zeros theorem. So what we're going to do is actually start by looking at our constant term, which is 6, and then I'm going to list out all the factors of the constant term. And in the denominator, I'm actually going to put all the factors of our leading coefficient, which in this case is 2. So those factors being plus minus 2, plus minus 1. And then you look at all the division at this point. So if I divide 6 divided by 2, that would give me 3. 3 divided by 2 is 3 over 2. 2 divided by 2, which is 1. And then 1 divided by 2, which is 1/2. And then we divide everything by the other term in the denominator, which is the 1. So 6 divided by 1 is 1. 3 divided by 1 we already had, so we'll skip that. 2 divided by 1 is 2. And then we have 1 divided by 1, which we already had as well, because that one is just 1. So this is a list of all our possibilities. So we have 12 possible zeros. So these are not our actual zeros, but it at least narrows down our list. So now there's 12 possibilities to try. So this is when we're going to start using synthetic division. So I can use synthetic division starting at any of these, and then I just want the remainder to be 0, because that guarantees it's a 0. So I actually want to do 2 examples. So I do want to go through one that doesn't end up working out, and then one that does. So first, let's say we try the first one on the list, essentially. Let's say we start with -3 to see if -3 is a 0. So I set up synthetic division, and then if we work through synthetic division, what we get is our remainder of -42. So if we try 3, same thing in terms of the setup. And now if we actually go ahead and do synthetic division, what we find is a remainder of 0. So that tells us, yes, in fact, 3 is a 0, which is what we wanted to. And now this allows us to break our problem up in factored form. So x minus 3 is one of the factors, and the other factor comes from the other numbers below in synthetic division. So the first one, 2, is the x squared term, the next one, 3, is the x term, and then the final one, -2, is the constant term. And then 2x squared plus 3x minus 2 factors further. So we end up with x minus 3 times x plus 2 times 2x minus 1. So now we have our function in factored form, so we're going to go ahead and complete the rest of the steps. Okay, so we factored it all out, so I'm just going to write down the factored form. So this allows us to identify the zeros. So in this case, the zeros that we have are +3, -2, and 1/2, which is if you set each factor equal to 0. So these are the zeros that we can go ahead and plot on the x-axis. So if we wanted to look for multiplicity in either case, so 3 has a multiplicity of 1, -2 has a multiplicity of 1, and 1/2 has a multiplicity of 1. So they're all odd, so our graph crosses at each of those zeros. So then we determine end behavior. So in this case, the degree is 3, the leading coefficient is 2. So that tells us that it goes down on the left and then up on the right. So once we go ahead, now we're going to try to complete the graph. I'm just going to plot a couple extra points. So I'm going to choose points in between our zeros. So I'm going to choose a point in between -2 and 1/2, and I'm going to choose a point in between 1/2 and 3. So let's try 0. And then let's try 2. So if we plug 0 into our function, we get 6. If we plug 2 into our function, we get -12. So one thing I might do so that -12 fits on there is I'll just adjust the axis a little bit. So let's say every tick mark this case represents 2 units. So 0, 6 would be right there, and then 2, -12 would be right there. So then if we go ahead and just continue with our graphing, it's down on the left. So I know it starts down here, and then it's going to move up towards that first 0. So we look at multiplicity of -2 is odd, so it's going to cross through. So it crosses through It goes to that point we found, which is 0, 6, and it has to turn back around because we know 1/2 is another 0. Another odd multiplicity, so it crosses through. So we found the point 2, -12, but then it has to turn around to go to our third and final 0. This point, again, another odd multiplicity, so it crosses through and then just keeps going and then matches up with the end behavior we expected for that graph.